Hello good people, I'm going to demonstrate molar calculations that need to take into account stoichiometric ratios. In other words, these are molar calculations that take into account balanced chemical reaction equations. Most alcoholic beverages are made by fermentation of glucose. This is a decomposition reaction where a mole of glucose gives 2 moles of ethanol and 2 moles of carbon dioxide. Our question is asking us how many moles of ethanol will be made from 250 grams of glucose. The balanced chemical reaction equation shows that the molar ratio between glucose and ethanol is 1:2. A common pitfall here is to say, well, fair enough, I have 250 grams of glucose, so I will end up with twice as much ethanol, 500 grams of ethanol. We cannot do that. Recall that balanced chemical reaction equations give a stoichiometric ratio, and a stoichiometric ratio is also a molar ratio. This means that I firstly need to calculate how many moles of glucose do I actually have. Then, once I have that, I can use the stoichiometric ratio of 1:2 to determine how many moles of ethanol I have. Alright. Let me firstly calculate the number of moles of glucose. The formula should be very familiar to you by now. Note that in this case, after each symbol, I have also added a GLU in subscript. This is simply to remind me that I am working on glucose. I want to distinguish my calculation for glucose versus my calculation for ethanol. I do not want to get the two confused. Now that I have my formula, I can substitute. 250 grams of glucose divided by the molar mass of glucose that I have calculated using the periodic table of elements. According to my trusty calculator, this gives me 1.4 moles of glucose when rounded to two significant figures. Now I can calculate the number of moles of ethanol. According to the stoichiometric ratio of the balanced chemical equation, for every mole of glucose, I will get 2 moles of ethanol. So I could say that the number of moles of ethanol is equal to number of moles of glucose multiplied by 2. And when I substitute, I get 2.8 moles of ethanol. Let me extend this a bit. What if the question asked for how many grams of ethanol will be made at the end? Well, now that I have the number of moles, I can also calculate the mass of ethanol. Recall that the formula for mass is number of moles multiplied by molar mass. And when I substitute, I will end up with 130 grams of ethanol when rounded to two significant figures. Note that this calculation involved more than just the triangles in the bottom right corner. We also needed to take into account the balanced chemical reaction equation. And once again, a balanced chemical reaction equation gives a stoichiometric ratio, which is also a molar ratio. This means that we need to determine the number of moles at play in a particular scenario. Let's do one more. Aluminium hydroxide is the active ingredient of many antacids. It reacts with the stomach acid, which is mostly hydrochloric acid, and neutralizes it. Our question here is how many grams of hydrochloric acid will react with 0.300 grams of aluminium hydroxide. We have been given a chemical reaction equation, but it is always a good idea to check if it is balanced. And in this case, no, it is not. So before we proceed, that is the first thing we need to do. We need to make sure that the chemical reaction equation is balanced. Right now, the aluminiums on both sides are balanced, but the chlorines are not. I have 3 on the product side and only 1 on the reactant side. So I'm going to place a coefficient of 3 in front of hydrochloric acid. Now I have 6 hydrogens on the reactant side and only 2 on the product side. By placing a coefficient of 3 in front of water, I will have fixed that. Everything is balanced. This means I can proceed with my molar calculation. A common pitfall would be to use just the masses. The ratio, according to the balanced chemical reaction equation, between aluminium hydroxide and hydrochloric acid is 1:3. So, if we have 0.3 grams of aluminium hydroxide, One might be tempted to multiply that by 3 and simply say we will end up with 0.9 grams of hydrochloric acid. We cannot do that. We need to calculate the number of moles involved. Therefore, the first step is to calculate how many moles of aluminium hydroxide we have. It is the same formula as always. Number of moles equals mass over molar mass. Once I have my formula, I can substitute in the values. And my calculator tells me that 0.300 grams divided by 78.003 grams per mole is 0.00385 moles when rounded to 3 significant figures. Now that I have the number of moles of aluminium hydroxide, I can calculate the number of moles of hydrochloric acid. According to the stoichiometric ratio, the number of moles of hydrochloric acid will be equal to the number of moles of aluminium hydroxide multiplied by 3. And when I substitute, I end up with 0.0116 moles when rounded to 3 significant figures. And now that I have the number of moles of hydrochloric acid, I can calculate the mass of hydrochloric acid. And that would be the product of 0.0116 moles and the molar mass of hydrochloric acid, which is 36.461 grams per mole. My calculator tells me that is 0.43 grams when rounded to 3 significant figures. Note that we are now definitely dealing with problems that require multi-step solutions. And while this can be a bit daunting, keep in mind that the number of moles is the key. That is all for now, and I will see you on the flip side.